So, good morning. Well, sorry for disrupting your conversations right now. Come back to those later, I hope. Right, so, hang on, where are we? Number one. Number two, what did we talk? How many of you watched the stream yesterday? Ah, there. Any frameworks in mind? Right, you watched the second last lecture. Okay, that's cool. Yep, you attended even. Yep. Mockito, right? What was that about? Well, you know, it's kind of intermingled, right? We scaffolded it a bit because they're all kind of used in various different cases. What was Mockito about?
Mockito.
Ah, there you go. Name gives it away, does it? Mockito, right? So it's kind of a framework, right? That was what we talk about. What did we talk about as well? Other frameworks? What did this do? No.
Testing UI.
Right, UI testing. So we had this one. And to make matters worse, what was the last framework? Yeah, framework that we talked about.
Behavior-driven.
That thing, yes.
Yeah.
Behavior-driven testing, right? Or BDD. Yes. What about?
Abstraction.
Yeah, that's right. That's the essence of development. But what's the purpose of it? When we have abstractions, but there usually isn't purpose. Which for the sake of doing abstractions, that's over-engineering. But there is actually a purpose. Yes, right? Exactly, right? So you can have tests that are human readable, close to, anyway. So that's precisely the purpose. So, if you look at it as impressions, it's not something we require you to use, but something you want to know about because we probably ask nasty questions in the exam. Testing is done. No, it's not done, not for you, but for me. So you kind of still need to use that as part of your principles. So, but another thing that I got across when talking to members of the class individually was, well, data formats. Did you ever systematically talk about different data formats for serialization? Any courses? Web development, www technology, as far as my Norwegian goes. So no, yes, no, somewhat. We used them, right? So which one did we use? What's the data structure we always fall back to if we do, communicate data? Okay.
JSON.
Computer science? Okay. Well, sorry.
JSON.
That's right. Right. We always ask you to use JSON, right? So we use JSON, right? Why do we use JSON? Cool name or no?
It's easy to parse.
Easy to parse, right? That's right, very easy to pass. You're right, that's spot on. I think I can't add anything to that one. It's very easy to pass. And what's the other advantage apart from easy to pass?
I guess it's like, very programming oriented, I suppose.
Yeah, but think from a debugging point of view a bit. What is a characteristic of that kind of data format? Is it super efficient? Why or why not? It's a matter of perspective. There's no. You could argue either way. What's the perk of JSON?
It's readable.
Exactly. Right. So it's human readable. It's super easy to debug. It's relatively easy to develop based on this ground because you can just read the keys and the values and see if your matching works up in terms of parsing it actually. Right. So that's right. So that's one of the things, and there's ample support for actually automating the conversion, let's say, of classes or object instances, of course, into JSON based on the field names, right? So it's one of the key benefits. But there are, of course, other formats out there that we probably need to talk about. What formats come to mind, please?
XML?
XML, yes, that thing, right? Do we use that anywhere?
I don't know. I think XML is used from some databases that are there.
You mentioned databases? That's the...
So I think it is used for that.
Yeah, okay, where else? That's actually right, yeah.
Well, it's used in web pages as well, isn't it?
There's XHTML, which basically is HTML embedded in XML, yeah, so that's right. So, yep. And yes, some web pages do this natively and just overlay it with CSS or something like this to to annotate text and stuff like that. But it's structurally different from HTML, the specification,
also
right?
have the Android Studio with its activities.
Correct, right? The layout
Yeah.
specification is in XML, right? So, okay. Other applications? Sounds like a medieval format for you? Who writes that like that nowadays? You have no clue. In the beginning of 2000s, that was incredibly cool format, right? We would, oh, cool, human readable format. We can finally understand the world, right? Okay, nowadays it's like, yeah, it's like super 2000s. Who cares, right? All right. I mean, even the iPad is 2010 already. So what? Point is, what other formats do we know? So we now have two. Is there more formats? There's another format you've come across. How many of you have been in the cloud course? And don't try to trick me, because I know. So, which other data format did we use there? For different purposes, not for transmission. We used JSON there, of course, sure. That's number one there. That's the other format. We used it kind of in one particular context. And the ops people amongst you should know it definitely. Towards the end of the course. That's right, so I need to teach cloud again. Okay, I see. You're all signed up officially. YAML? Yeah, similar, right? So it has kind of, what does it remind you of if you look at YAML format? Which one is the closest to? Structurally, syntactically. Is it more like XML? More like JSON?
Closer to JSON, I guess.
Closer to JSON, right? So it's also one of those very sparse formats where actually it's about minimizing verboseness, right? So, and you kind of captured the essence of what those formats are to some extent about. And today I want to go systematically through those formats, because while we usually think about this as a natural progression from really old format to really new and hot format, I want to extend your horizon a bit in the sense that you want to think about it systematically, because everything comes in cycles, right? You know that about life and stuff, also in computer science, bad. So, point is, whatever the features particular formats have, even though they may not be actively in use and so on, those features will come back and be relevant again in 10 years. There will be the next new fancy format, and you guys will know already what the features will be, because they will just basically reinvent the wheel, but have a new syntax, right? A bit like programming languages, right? So, in Go, for example, the inverted type and argument specification, right? For example, in the function signature, right? Look at Kotlin, happening the same way, right? So right now it's really hot to invert this, parameter signature for whatever reason, right? Perhaps they'll convert it back. So basically, there's also an element of trend in many aspects of technology that have some sort of justification, but not necessarily a strong justification. And similar for data formats. So just to get out some examples. So we talk about XML, JSON, and YAML, of course. Those are main three topics we talk about. But we also extend a bit and look at other things like Beeson. Who's that? A rare animal missing an eye?
We use it in the MongoDB cloud.
Correct, right? Why? Right, yeah, okay. That's sensible. We get there. And protobufs. We briefly talked about them. In which context? They're also a bit 2010 already, but no? Damn, okay. I give the service lecture again as well, so prepare for next week, guys. No, so protocol buffers are a form of abstract specification of data format for serialization purposes, and it's programming language independent. We talked about it in the context of IDLs, interface description languages, right, for inter-process communication Android. Forget it, we come back there. So I just want to get the message across. And my plan for today is to run through some of those formats and point out some intricacies and some features that may not be as well known. Because we usually fall back, okay, we need to transmit data, let's do some JSON and everything works. Sure, it works because you develop it from scratch, right? But does it have all the features you need? Well, sometimes you may need to consider different formats. So let's start with history. Yes, I like history lessons because that's what we learn the most, I guess. XML, right? So it's actually called Extensible Markup Language, right? So what does markup stand for actually, or why markup? Anyone? What's usual markup mean in the context of text processing? Well, so it's basically the, additional meta functionality like highlighting, making something bold or formatting, things like this. Meta information about a given document, right? So, and the idea was there. Okay, in addition to just transmit text, right? ASCII, right? We know that. Can we embed more structural information? Think about a document, right? Book, for example. Yeah, I'm going too far. But if you think about a book, right? The book is not only structured in, well, we have sentences and stuff, right? That kind of, yeah, sentences, cool, yeah, good. Okay, we also have paragraphs, right? So that actually structure sentences and organize them coherently. So we have, organization in a book, for example. Then also we have chapters and things like this, right? So in this structural information, of course, you can express it in ASCII as well, right? By having, line breaks and all that kind of stuff. But what you're in fact doing is, you kind of embed encoding structure into text, right? So it's actually you're mixing structure and content. Yeah, by having embedded line breaks and so on separate headers and stuff like this, perhaps you make them bold just to ensure they should be interpreted as chapter titles or something like this. But fundamentally, it's basically you modifying the text to actually clarify the structure. Makes it kind of readable, but still makes it very hard to process because the semantic information, the higher layer, okay, what is text, what is, for example, chapter information and so on, is kind of lost unless you kind of write a parser against your specific conception of what a text is. And that was the role of the markup language. Okay, can we encode structure along with content and separate both of them? Right? So we have content that's usually the stuff between tags, right? Text, opening tag, close tag, content in there. And then the texts themselves describe what you want to apply or do with the text, the content in between, right? Is it, for example, a paragraph, right? Paragraph start tag, text, paragraph stop, end tag for paragraph, for example. Or do you want to do markup? You want to make something bold. So in HTML, for example, coming back to that one, you would signify that, having like a leading tag that would indicate that something is bold and a closing tag. And similar in XML. So you could have kind of nested text structures, right? So where you, for example, make certain words bold, some other italicized, or you embed footnotes into flow text and things like this. So suddenly the whole thing becomes kind of parsable. That's the idea of markup. Yeah? So it's literally about this meta information that you can do in Word, basically by highlighting text, right? By having comments in there and things like this. That was the purpose of the language. And the original purpose of this whole structure was, hang on, we have this internet thing, in 1991 in particular, and we still don't have a proper way of systematically describing documents on the internet. Of course, there was HTML, and HTML is, what's the problem with HTML? Why isn't that a beautiful solution already? It kind of is because it's still there, but I guess. What's the problem with HTML? Did I say that right? I think so.
It has a limited number of elements or tags.
That's part of it, yeah. What else? Well, HTML goes slightly further because fundamentally HTML is an input for our browser engines, right? You give them HTML and they spit out beautiful stuff with fancy colors, and you remember the blink tag, which is forbidden, and things like this, right? So, but fundamentally it's geared towards presentation, right? For user, as user input. Here, the idea is, okay, can we describe, for example, well, any document really, in a machine-readable way? So it could be a machine-to-machine communication. It doesn't require a human being. You could process it in a way so it's, presentable on screen, by applying CSS elements and so on, and beautifying things and so on. All good, of course, that's done. But it's most often actually to share information on a B2B level, right? So we actually can write concepts that have rich structures. And documents or letters in particular, they consist usually of a header and body, right? Those kind of things, right? Like an email as well. And that was one of the purposes of using XML to represent comprehensively that kind of information. Yeah? So very comprehensive in description of structure. I'll give you some examples, and of course a broad application. And there's an ample number of formats that are based on XML, right? So just some in there. Are there some formats you don't know about? Which are common? I hope ISS is somewhat entrenched at this stage. Okay, no one does the sum and 2 yet. Okay, slightly worried. Atom, yes. What is Atom for? No? Okay, it's competing format to RSS, so it was kind of another reader format where you basically can have digests of blog posts and the like. So it's kind of a competing format, but also based on XML, slightly different specification, right? But you guys have looked at RSS, right? You know the structure of it, right? Please, some not, yes. Good. So we have some format here. Then there's SOAP. What's that one again? Did I leave my caps lock on and got it wrong, or is that something else? Where's it used, SOAP? No? Web services? Yes, so perhaps? Also 2000 stuff, right? Yeah. So the idea is there, when XML came up, the idea was, okay, let's use it for everything, as usual in life, right? So you have a fancy new tool and toy, you want to play with this. So people thought, okay, let's not only use it for document description, so the static stuff on the internet, where you basically, encode documents in XML and put them on some server, but also use it as a kind of description language for web service interactions. So there was this thing called service-oriented architecture in the early 2000s. The idea was we need human-readable web interaction. So kind of think about the precursor of REST, right? At that time, there was no specific. So the idea, instead of working the REST way, where you have a fixed set of methods that you can operate on using web service, that was kind of, yeah, you roll your own kind of thing, right? So basically, okay, you devise a protocol for interacting with a web service, which is based on the specification SOAP, but fundamentally specific to your service. For example, post order, read delivery node, or things like this. Right? You kind of model around your business problem, but you have a language that allows you to model around this way. So kind of think about a precursor, right? Whereas we now, in the resource-based interaction in web services using REST, we kind of model everything around standardized interactions, like the CRUD operations, right? Create something, read something, update something, delete something, right? So that was kind of a precursor. No need to waste time on this. Really, it's a nightmare, but it has exactly this header body kind of structure. Header, what are you going to do? Body, what's the payload kind of thing, right? Think about it this way. SVG? What's SVG? That's worthwhile knowing, actually. Slightly out of, how do you say? It's not really currently hot, but it's actually a very valuable format. What does it do? What's SVG? I think the web designers amongst you may like it. Yep.
I guess it's for drawing graphics.
So yeah, exactly, right? So what's the particular perk about it?
It's because you can scale the images, you can zoom in, and they won't do.
So it's an XML-based vector format, right? So you can have a vector graphic format, and browsers can usually parse it. So if you open a SVG file, the browser will show it as it is. But if you look at it, it's just plain XML. What does it do? Well, most of you are in graphics, so it basically describes points, for example, and the relationship between points, and then say, well, draw something in black in between, let's call it a line, on things like this. So basically it has basic elements, geometric elements that are combined to make nice images, right? If you draw something, you usually spit it out as a JPEG or PNG, but here the idea is, well, keep the internal structure, the semantics stable, right? Encode them, and then you can do things like, for example, stretching the image, meaning scaling the image, and you don't have any artifacts, right? So you can still apply anti-aliasing, for example, and smoothen the edges. So it's very convenient for use on web pages for different devices and things like this, right? So downside? What's the downside against PNG, probably, or JPEG? What's the problem with XML in general? Why people don't use it? If it's so beautiful and used for everything and solves every problem. Yeah. It's very verbose, right? Which means in practice?
It takes us a long time to work with, I guess.
Okay, but
how big files?
Yes, huge files, right? So it's purely text-based and massive files. We'll see it in the structure later. And those ones are huge, right? When you talk about a JPEG of like 50 kilobyte or something, usually means half a megabyte of SVG. Right? Because it really encodes every dot that you have in there, every line in there, every circle structure and so on, the colors and so on. And you have even multiple layers, so you can actually move elements across. It's actually cool if you have an application that spits out SVG, you can modify the output, right? So you can actually shift, you can still modify the image. For example, you have a graph and the label is in the wrong position, you can actually still move it, right? That's cool. Downside simply it's just a lot of space. So there's a lot of that kind of stuff. So of course the one application is also document formats such as Word and OpenOffice and all that kind of stuff, because they lend themselves very well for this systematic description using XML text and so on, right? EPUB, MathML. What's EPUB? Yes.
Ebook format.
That's correct, right? So it's an XML-based ebook form. So if you open this with a text editor, you actually see a structure. Right? So it's quite nice learning about how you could use it for document description. MathML. Any wild guesses? Come on, put yourself out there. Okay, right, of course. So it's basically you can express equations, right? So and usually you know that relatively complex symbols and odd positioning and so on. Basic idea is to standardize that, so you can write formulae or equations in ASCII basically, and it does the formatting for you. Pretty cool, right? So similar to LaTeX, if any of one of you with this, the math package does similar things. Okay, cool. Yes, since when do we have this thing? 96. Old, eh? Medieval, yes. Fine. We had internet already, but it's still kind of an old thing, right? So latest specification 2006. So very slow moving format, very stable one, right? So it's also good to know sometimes. You need to rely on stability. So how does it work? Well, you usually have those tags, you have attributes and elements, and an XML declaration. So basic idea, well, here's an example. You have an XML. Usually you have a declaration which version of XML is involved. So it's cool, it's versioned. Very helpful because you know which functionality it actually uses. Latest one is 1.1, but you know the difference are marginal. And then you have some sort of opening text and always corresponding closing text, right? You need to expect this. Parsing point of view, a bit annoying. And of course, you need to figure out the opening text and closing text, which you're doing right now in ISS, right? So parsing the ISS feed. Ah, good, thank you. Some confirmation. And you have arbitrary number of nested elements as well, right? So we see that here we have some sort of structural encoding, a set of bright stars, right? Which consists of name, magnitude, distance, whatever else. But the pattern is always the same. We have this opening and closing tag concept, right? And content somewhat in between, right? So it may be of different type. It may be numerically or text and so on. So it's quite flexible as long as it's mapped. So key characteristics for well-formed XML, that's one of the key terms there, is to have a single root element. So we wouldn't be able to have multiple of those ones, not allowed. You need to have a overarching, you kind of need to think about it like a tree structure, which has some root element eventually. Even if you want to model multiple bright stars, you can do that, but you need to have a higher level element, for example, like galaxy or something like that. Right? So it needs to be a single root element that is at the top. We have this matching, we have the tagging, and we have, if we have attributes, there's none in those examples, then we need to have unique attributes within those elements. Show you a slightly more involved example, so perhaps to gain to see more of that. So that's another example just to bring up. So for example, same pattern here. We have a simple example, bookstore, right? So multiple books in there, book 1 and book 2 and all that kind of stuff, with a lot of nested stuff. You see here in the book on top, you see ISBN. That's an attribute because it's in the start tag, right? It's embedded in the start tag. That needs to be unique. You can have multiple of those ones. So it's a good way of annotating. Of course, you could encode this as actual elements themselves, possibly, but you know it probably would be a waste of space. So generally, if it's a fixed relationship to a particular book, then you would encode them as attributes. So it's basically one entity that you would encode. And then you have, in this case, a title, authors, in fact, multiple authors. You can break it down, first name, last name, and things like this. Next book, right? So the whole structural components are embedded there. So quite straightforward. The roots are actually surprisingly simple. But one of the cool things, actually, that it has is built into. Well, if you think coming from a database perspective, right? What's an issue here? How could you improve the efficiency of the representation? Or what bugs you if you're a kind of database-minded person, if you look at this? Keyword normalization. There's some redundancy in here, right? For example, 2 books, right? In fact, it happens so that in fact the first author there and so on, the first author here are the same, right? So there's a lot of redundancy in this representation, right? So of course, and that is the verboseness that you mentioned before. That's of course a problem. And the neat part is XML actually provides provisions for this. You can actually go as far as to, hang on, let me do this systematically. You can go as far as to kind of normalize stuff by having internal references. You see here, we have still this book here, right? The book now being like 6 lines, and then you have reference to the authors, right? So you author, and they're identified by an attribute, you know, for in this case, JU and JW, and then independent of the books, at the end of the books, you actually have the author specifications, which are now externalized, right? You have them here, separated from the books. So what I want to say, what I want to get across here is, you can actually represent relational structures. Right? Suddenly you can externalize certain elements and you know, not need to represent the complexity. So that's a powerful feature, having those references. And of course, you can then normalize in a way that you, for example, have this guy only represented once, but used in multiple books and things like this, right? By basically kind of a foreign key concept that you know from databases already. So XML allows you to do that out of the box. So it's part of the feature set in XML built in. So it's quite worthwhile. And it's precisely what you mentioned before. Where is it used? Well, databases for that reason. Because it can represent the internal structure of a database instead of using DDLs in order to describe data structures in SQL format. It can, in theory, just spit it out as XML in this very way. Right? And in fact, most relational databases actually support output in XML. So even SQL Server of Microsoft, for example, you can selectively have output in XML. Internally, of course, still represented in SQL, but they convert the structure in parsable XML. So that's actually quite neat feature. And one of the key things, well, we know about the syntax right now. It, of course, bears a certain element of complexity, right? Having this nested structure and having the semantic relationships and so on. And what XML does there, because it's focused on interoperability, so not only representation of formats, but also parsability by machines, right? So sending documents left and right and so on. They thought about certain provisions. By the way, it's standardized by the W3C, right? The Internet Standardization Organization in the widest sense. And what they devised as part of XML was a so-called, what they refer to as an XML processor. Right? So the idea is that you can run an XML document through a processor that does this check for you. This check, right? Single element, opening and closing tags, and unique attributes and so on. So very basic rules, but at least you know if you run your document through this processor, or parser as it's conventionally called. So when you use the parser, that's the thing in W3C lingo. It will tell you, well, that's actually valid XML or not. Cool. Yeah? So quite straight. It can basically check the world formats. So far, so good. So now we have parsable XML. Right. Given is that enough? So do you think, okay, now we have a format, we can parse it and see if it's well formed. Should that work for interoperability? Does it solve all the problems we could probably have? Well, yeah.
No.
Yeah, no is probably the answer. Any wise in mind?
No.
Think about the structure. Is there any way of us specifying structure of a document? We're going to say, well, this document is a well-formed XML document, but how can we say, well, a particular field needs to be filled or is required, like in databases as well, right? Where you can say that certain fields are required, some are optional. We can express cardinalities, one-to-many relationships. Per se, it doesn't look like it, right? So we kind of rely on this. Well, this was considered one of the key operability challenges, because the idea was that, well, you have companies that interact with each other, but actually don't really want to get insight into your respective processing. If you work with JSON right now, you kind of need to figure it out for yourself, right? So you kind of write your structure, you come up with your structure, and you kind of internally validate it, right? Check, oh, cool, are all fields filled? Hang on, is there, the structure satisfied? Does it pass into a proper struct in Go, for example, in Golang, if you want? So you need to do a lot of checks and validation yourself. Implicitly, you're encoding the schema in your application. Yeah, your application needs to take care of it. So what XML offers is quite cool. There's a concept called XML Schema. And that's actually a nice thing. So left side would be this old example there again. On the right side, the corresponding schema. So what you can actually express here is, hang on. So you see, it looks slightly different. Instead of just having the name text, we have a prefix XS, which stands for XML Schema. So it's just literally that expression. So what did it say? Well, you know, we have an element called bright star. Yeah, probably works, right? And then contained in the bright star, we have a complex type, right? So so basically, a complex type is a combination of different elements. Think about an object, right? Object is basically composed of different fields, right? So, which is specific. So think about read it as object, and then there's an assumption of a sequence, right? So ordering assumption. It's not a set sequence, and saying, well, there's an XML element with a name. There's an XML element with a name, magnitude, and distance. And even better, you can specify the types, right? So you actually need to require this to be a string, this to be a decimal, and this to be an integer. So it's really refined. So that's the key idea here. So you can kind of automate it, and if you then have a XML parser that is, of course, doing validating, and you inject this schema file, XSD, there was a predecessor called DTD, was incomplete and had some certain shortcomings. Forget that thing, that's history, no one uses that. But this XML schema, it actually can tell you two things now. Not only if it's well-formed XML, basically does it have the syntactic requirements, but even better, does it actually satisfy the structural requirements that were specified in the schema? Is, for example, magnitude a number as opposed to a string, for example, things like this, right? So that's actually kind of neat, because in this case, you don't no longer rely on an end application to do the validation for you. Well, you specify a document, you specify the schema, and then you run it through a parser, and you know whether it's correct or not, right? Before you actually engage and encode anything. At this stage, you can assume you have correct XML, and it's relatively easy for your application to parse and use. Yeah. Does everyone appreciate the benefit of this approach? You're kind of externalizing the validation, right? So you don't do the internal validation. So well-formedness, yes, sure, cool. We need to do that with JSON as well. I mean, in fact, most JSON files will blow up if they realize they get incomplete JSON. If they're, you know, closing brackets missing. The well-formedness is kind of the assumption. Okay, that's how a document has to look like if it's JSON. But here is kind of the encoding of the application-specific schema, and that's really, really nice and powerful, and that's very unique to XML. But it's also necessary if you think about much more complex formats. So coming back to this bookstore thing, if you look at the schema here, well, you know, it's actually kind of involved, and I'll just show you, because just to explore some of the feature set that it actually provides, right? So we have a leading element, which is this bookstore thing. Then it's containing multiple complex types, objects with the name book, right? So the name book. It is associated with a certain book type. It's even better. So there's a book type that's associated with this, and min occurs, max occurs. What does that mean? Well, it's cardinalities, right? So you could say, well, what's the minimum number of books in a bookstore? Well, you know, 0. Maximum, whatever, right? So you can actually express cardinalities here as well. Similar for authors, right? So we expect to have authors and books in there, and we can have a large number or small number of them. Then we have an externalized reference to, for example, the book key. Book key, where's book key? Hang on. Right, so the key, that's actually pointed to book, and we have a reference to the ISBN, the same for the authors. So the references are down here. And here you say that, if I get that right, so there, yeah, there's the field author key ref, which has to point to book author's auth. So basically it ensures that every the component that you specify in the author reference is actually in the author set. So you basically can't declare a book as an author of a book. You need to declare an author as an author of a book. Right, makes sense. So you can specify this path in XPath, which is kind of a tree navigation, a tree parsing functionality in XML, for example, and you ascribe certain identifiers for that location in XPath. So and then this way, you can validate that if you have this previous schema encoded, so you have books, you have externalized authors, you have references to authors from books, this will validate with this particular schema. So basically, if you are dealing with a third party, instead of specifying an XML, you specify the schema and tell, here, code to that thing, then my information system will consume your stuff, right? We will never know this and never feel this, because usually when we develop something, either we get, in your documentation in JSON, you get a JSON example, you just code against it and debug it until it actually works, number one. Or we build the whole thing ourselves, so we don't need to bother, right? Because we kind of know the specification because we made it up, right? But if you think about that, you're dealing with multiple parties, complex interaction with multiple parties, and you don't know about their underlying systems. So we're talking 2000s, that was the time where you wouldn't necessarily make assumptions about programming languages and operating systems that people use. So right now it's kind of a bit more homogenized, I guess, because all the mainframes are out of the window. And it's, you can assume it's usually Windows or Linux you're dealing with, kind of thing, so it's a lot easier there. But the idea was there, don't assume anything about the programming side, just think about the specification there, right? So, and if you're in this role ever, then it's probably worthwhile, digging the history book out again and thinking about XML as a possible pathway, right? Just to put this out there. Cool, so this is that stuff you heard about before? Yes, well, why don't you talk to me? Come on, guys, why did you tell about it?
Database course.
Database course. They talk about everything then, right? JSON as well?
Cool. I remember the XML validation stuff.
Good, okay. Good. Anyway, cool. Need to remind me. Because I often get questions, okay, why do we have XML around and that kind of stuff? So I'm wondering, okay, I want to clear that up for now. So let's skim over that. So that's cool. What do we have? We have a lot of stuff. We have kind of present foreign keys, we have type references. So that was the thing about I mentioned before, that you can actually indicate that an author has to be an author in a book. You have nesting components. You can assume ordering by having sequences and cardinalities, right? So, okay, rough idea about XML. So the other thing, of course, is JSON. You're comfortable with this one, and that's the simplest language of the planet. I think that's probably the good way of summarizing it to some extent. Quite old as well, since '99. And it's integral part of JavaScript, right? So no surprise, it's called JavaScript object notation. And that's part of the reason why it's so simplistic, because in JavaScript, well, what's the key characteristic of JavaScript? Typing. Strongly typed, weakly typed, statically typed, dynamically typed.
Types, like variable types in JavaScript, they can be anything, more or less.
Yeah. So the inherent flexibility of JavaScript is kind of embedded in the structure as well, right? So that you're very unspecific about type declarations, for example, right? Something doesn't necessarily need to be a string, it could be something else, and they have no clue, right? So you need to figure it out at runtime to some extent. And then kind of the idea was to be able to transmit JavaScript objects, so complexity constraint to JavaScript objects over the wire, basically it, right? So quite lightweight, human readable, dynamic typing. And what it basically has, it's basically consisting of two things. One of them is kind of a map representation, right? A collection of string and value, you know that stuff. And the other thing is a list of values. That's it. That's the only thing you technically can encode in JavaScript. Of course, it supports different types, right? So some typing is involved. String, number, object, array, and then of course the Boolean types and null, right? Do you consider this strongly typed or weakly typed? And why? Please?
Exactly, what does it mean to be strong and weak?
Yeah, okay, cool. So the idea is when different programming languages, we're talking about different type systems, right? And they usually vary on a scale from very strongly typed to weakly typed. And that usually means if you can firstly dynamically reassign a type of a particular value, that's kind of dynamically typed and usually points toward the weaker direction. Not necessarily, we'll get to that. And the stronger types mean is that you really refined about the type specifications that you can use. Example. So string is one way of course, characterizing a string. And we have as a second element number here, right? So can you think about other qualifications, more refined qualifications for numbers?
We have the ints and floats and doubles.
Exactly, right? Exactly. And the more refined this structure becomes, right, the more fine-grained the tree is, the more strongly typed the language is considered to be.
Okay.
Yeah. So if a string language only offers you number, generally on the weakly typed things, if you have float, you know, you have double, you have long, you have short, and you know, you have byte representation, for example. We don't have those here, right? That would be on a stronger side kind of thing. So there's the continuum is kind of never ending because you can push it down to byte level in the end. But for example, Java, for example, would be more on the strongly side of things, type side of things. C++ as well. Even though it said auto in C++ 14 onwards has automatic type inference. So we have this auto type. It doesn't mean it's weakly typed. It just means it determines the type at runtime. But it's still the same type system, right? It will figure out basically by looking into the assignment side what the type must be, right? If it's a string, well, surprise, surprise, it will be a string. If it's an integer only, it will assign the most plausible type, which would be an integer. If it has a dot in between, double, right? So if it's small enough, perhaps float, right? So there's a bit of a probabilistic element in there, but still it falls back into the type system built into the language. JavaScript is super weakly typed, right? So you assign something and yeah, at this stage you stop caring about what it is technically, right? So you kind of hope that things still work out. That's usually my impression, because most of the time you deal with JavaScript, the term you most often read is undefined, I guess. No? No? Okay. Was I the only one making that impression, having that impression? Okay. Must be my programming skills then. Anyway, but back to the point here. So we have a weakly typed structure, right? And that's kind of reflected here. Very simple, very straightforward, but kind of useful to a certain extent. But super nice for prototyping, right? So trying out stuff. You don't want to conceptualize an XML structure and write the schema to it and then code against it, realize you need to refine this and stuff like this. So it's a lot more complex. Here you can be really ad hoc in doing it, right? So so those are the types supported. Certain strings, what do you need to do? Well, you know, first of all, strings need to be in quotation marks just to help you read the structure in quotation marks, and within you can use any Unicode string with certain exceptions that are listed there. So those need to be backslash because they're special characters, they have special meaning, right? So for example, B means backspace, backslash N is a new line feed and things like that, right? So they're all encoded there as well. And the number format is also quite funny. Those are the conventions you need to commit to for a number format. What kind of numbers can you express with this representation? If you spend some time with it, you actually can start to like it. Well, you know. Well, point is, allows you to have signed numbers, right? The minus symbol in the beginning, for example. You can express all digits, of course. Then it allows you, including 0 as well. Then you have a decimal point followed by a digit again. So you can have, you know, 0 point something or negative 0 point something. And then you have this E, basically you can have scientific notation, right, for writing exponents as well. So E, so to, you know, exponent plus or minus digit of choice. So basically the idea is you can express any kind of number. Integers, signed integers, doubles, and the scientific notation for exponents. Yeah, so that's the idea. Right? Cool. All right, that's it, nothing else. That's the whole JSON thing. So from a specification point of view, that's very cheap. Right, so I mean, there's not much to think about, and that's why it becomes so easy for you to write it, right? I guess, and use it to some extent. And here's the thing, right? So if you compare those two ones, XML, the dinosaur, compared to JSON, kind of a bit more Giselle kind of thing, it's much more lean, right? So in terms of structure, right? So you have, and one of the key aspects that are put forth by opponents is simply the fact that there's a lot of redundancy here, right? So you have every time there's opening and closing tags. It's just, you know, around 1/3 is just additional payload, unused payload, right, in XML. Whereas you don't have the complexity at all, because the only thing you need to deal with is curly braces. The rest is largely self-explanatory. Right? Okay. So JSON. So, but again, apples and pears, right? So it's not the same thing. So if you say XML is not good and JSON is good, that's usually not a qualified answer in the exam. Because it simply doesn't have any of the richer features. It doesn't have schema conception. It doesn't have per se a validation approach, right? So it has a very weakly typed structure. So if you want to use programming languages such as Go, Java, C++, whatever else, you kind of need to infer your types all the time, right? Because you only have this very flimsy number conception there, but you can't assume that's a float, for example, right? So you need to test for it. Makes it expensive in terms of processing, or can make it expensive. If you do the green field approach and you write your stuff all yourself, okay, cool, easy, right? Because you know the convention, that's very easy to assume stuff. But if you're dealing with third parties, it's actually not such a good idea. You kind of need to do quite a bit of validation, right? And that's part of the reason why specifications in JSON usually are by example. There's nothing else they can provide. Because the specification is too weak And your requirements are usually stronger than a specification, right? Because they encode, for example, a float. Well, if you specify it in JSON itself, we'll just say number. So it's very unspecific in terms of what it actually means. So that's why always you need to provide examples if you describe an API in JSON, right? Cool. So just to get that across. So slightly different perspectives. Yeah. Thoughts? Too much history? We're still on board? Yeah, okay, whatever, right? Yeah, okay. Data types boring? Okay. Well, you need to know them eventually. There are more of them. I'll give you a break, 10 minutes break, otherwise you will fall apart here. So after that, I'll briefly talk about YAML, and then we go into the serialization formats, because those will be relevant for actually transmitting data. What we saw up to now was really rather about representing data, but of course transmission, but we're moving on towards more efficient approaches. That's the key idea. Okay, thanks for your attention so far.